Good morning friends, welcome back to Panika Tutorials. In the last video, I have discussed how to insert a node in the double linked list. I have discussed the three scenarios: inserting a node from the beginning, at the end, and also after the particular position. I hope you have watched that video. If you did not watch that video, I request you to go back and watch that video and come back to this video. In this video, I want to discuss how can we delete the nodes from the double linked list. We will discuss the three scenarios. One is deleting the node from the beginning, deleting the node from the end, deleting a node from a particular position. So I request everyone to watch the complete video for better understanding. First, let me give an overview about the double linked list. Then I will discuss these three cases in detail. Now look at this double linked list. Double linked list is a collection of nodes, and each node will have the address of the previous node, data, and address of the next node. As it is the first node, address of the previous node will be null, and as it is a last node, address of the next node will be null. Look at this node. Address of the previous node is 200, so it is stored here. Address of the next node is 400, so it is stored, and it is having the data called 30. And we will have two pointers. One is head and tail. Head will be pointing to the first node in the double linked list, and tail will be pointing to the last node in the linked list. Is it clear? Now we will discuss how can we delete a node from the beginning. Deleting a node from the beginning means the first node you have to delete. Is it clear? So now let me write the user defined function called delete at BEZ or begin. Let me write it. Okay, it is a user defined function. It is your wish what name you want to give, but you need to follow the rules of an identifier. Okay, so what you will do is that first you will check if head is equal to null, then what you can say? Double linked list is empty. So you can write printf list is empty. Okay, you can write \n and you can close the curly braces. Else, if list is not empty, then what we have to do? I will discuss for you. First thing is that we need to create a one pointer, okay, of strut node. So strut node start temp is equal to head. We need to assign the value which is there in the head. So now take the pointer variable called temp, and we have assigned the value 100. So now temp and head, both the pointers are pointing to the first node. Now I want to delete this node. Okay, so to do that one, first I need to traverse the head from this node to this node, because if I delete this node, now this will be the first node. Okay, always the head should be pointing to the first node. So what I will do is that I will write head is equal to head of next. Okay, now head of next, head is 100, 100 of next is this one. What is the value? Is the 200 that you are assigning to the head. Now head is having the value 200. So now head is pointing to this node. Okay, still temp is pointing to this node. Okay, is it clear for you? Now what you have to do? You have to write here, because if this is the first node, then address of the previous node here should be null. So how you can access head of previous is equal to null, because now head is what? 200. 200 of previous is this one. You are assigning the value null. So meaning is that this node is not pointing to this node. Is it clear? Are you able to understand it or not? Then what you have to do? Now head is pointing to this node. This node is now the first node. That's why it is null. Now what you have to do? Here you should remove the 200. You have to make it null. So what you will do is that temp of next is equal to null. Okay, so temp, which is 100, 100 of next is null. So now this link has been down. Is it clear? So now this node is not connecting to any other node in the double linked list. Now you have to release the memory. How to release the memory which is allocated during the runtime? Using the function called free. Here we have to specify the pointer which is pointing to this memory location, which is temp. Okay, Are you able to understand? Then memory will be released. If the memory has been released, okay, it is done. Now look at here. What is temp is consists of? Temp is consists of address called 100. That memory is not there. Now we will call it as a dangling pointer problem because the pointer is pointing where the memory is not existing. So to avoid the dangling pointer problem, we have to assign temp is equal to null. If temp is equal to null, then it will become a null pointer. What is meant by null pointer? Null pointer is a pointer which is not pointing to any memory location. Then it is good. Instead of pointing to some non-existing memory, if it does not point to anyone, that is good. Okay, so let me close the else. Okay, let me close the function. If you want to display what data you have deleted, before writing temp of next is equal to null, you can display like print of this is the value you are deleting and temp of data. That you can do it. So this is the way we will delete a node from the beginning in a double linked list. Now let me discuss how can we delete a node from the end. Okay. Now delete at the end. Okay. Let me modify this one. Now also you can check. Okay. If tail is equal to null or head is equal to null, then also you can say that linked list is empty. If linked list is empty, then what you can say? You cannot delete any element. Am I right or wrong? Okay. Else. Again, I will create a temporary pointer of strut node. Okay. This time I will assign what is the value is there in the tail. Now what is the value is there in the tail, which is 400, which is pointing to the last node. So now I have created a pointer called temp. Okay, see, look at this one. This temp pointer is only within this function only. So don't worry. See, we have discussed deleted beginning, that time also it is done. But this declaration is a local declaration. I hope you have understood. If you don't know about the scope of the variables in C programming, I have discussed about the local variables, external variables, global variables, all these things. I request you to refer that one. Okay. Now temp is equal to tail. Now temp is also consists of 400. Now temp and tail both are pointing to the last node. Now if you want to delete this node, okay, what you should do here? Here you should make it as null. Okay, before that one, this tail should be pointing to this node. So what you will do is that tail is equal to tail of previous. Okay, look at here. Tail is 400. 400 of previous is 300. That you are assigning to the tail. Now this tail is pointing to this node. Is it clear? Are you able to understand? Then what you have to make here? You have to make here as null, because if this is the last node, if you delete this node, this will become the last node. If this is the last node, then this next should now have the value called null. Then only we can say that this is the last node. So what I will do is that tail of next is equal to null. Okay, so now here null value will come. Okay, if null comes, this link will be down. Okay, but still this link will be there. So now you have a pointer called temp which is pointing to this one. So what you will do is that you will write temp of previous is equal to null. So then this one also will become null. Okay, is it clear? Now this link has been down. Okay, now you can release this memory using the function called free of temp. Then this memory will be released, but still temp is consists of address called 400, which is not there. So the temp is a pointer which is pointing to a non-existing memory, so which is a dangling pointer. So to avoid the dangling pointer, we will assign null to the temporary pointer. So here we will make it as null. Done. We have deleted the node from the end in the double linked list. Let me close the else. Let me close the function. So this is the way you can delete a node from the beginning in the double linked list. Now we will discuss how can we delete a node from a particular position. Okay, for doing that one, let me draw the double linked list. Okay, then we will delete it. Okay, is it clear? Let me create some nodes 1, 2, 3. Okay, 3 nodes are sufficient. Let's take it simple. Okay, why to waste the space? Let's take that this address is 100, 200, 300. Here data is 10, 20, 30. See, for making you understand, I'm taking like this. Is it clear? No, don't think that always the addresses will be in the increasing order. Here you will have 200, here you will have the null, here you will have the 100, here you will have 300, 200, null. Is it clear? I hope you are able to understand why I have written 200 here, 100 here, because this is address of next node, this is address of previous node. Once it is done, the links will be successfully created, and we will have two pointers called head, which is pointing to the first node. We will have the tail, which is pointing to the last node. Is it clear? Now I want to delete a node from a particular position. Is it clear? Delete at particular position at POS. Let me write it. Okay, to do that one, what I will do is that I will declare two variables of integer POS and I. Okay, then I will ask the user to enter the position. Printf enter the position. Okay, once the user has entered the position, I need to read it. Okay, is it clear? With the help of scanf function. Scanf %d ampersand POS. Now we will declare some count variable, and then we will call the user defined function called length. What is this function will do? It will compute the number of nodes in the double linked list. Already I have discussed in the previous video. If you don't know how to compute the number of nodes in the linked list, I request you to watch that video. There I have defined the user defined function called length. Okay, then I will check if the user entered the position is greater than the count. See, now the count is what here? 3, because the number of nodes in the double linked list is 3. If user has entered the position is equal to 4, meaning is that he want to delete the node which is there at the 4th position. If the double linked list does not have the 4th node, how can you delete it? It is a invalid position. Am I right? So then you have to display printf invalid position. Is it clear? I hope you are able to understand it. Okay, because whatever the user is entering, it should be a valid position. Else, if user has entered a valid position, then what you need to do? Okay, first thing is that we need to declare a temporary pointer of strut node. So strut node start temp is equal to head. Okay, we are initializing the pointer called temp with head value. Head is having value called 100, which is an address. Is it clear? Okay, now head and temp both are pointing to this node. Suppose let's take that user has entered the position as 2. See, if user has entered the position 1, then you can simply say that delete from the beginning, that you can write it. If user has entered the last position, suppose if length is 3, if user has entered the position is equal to 3, then you can simply call as delete at end. Okay, is it clear? If user has entered other position which is less than the count, then only you have to do this one. Is it clear? Are you able to understand? Suppose let's take that user has entered the position as 2. So this node he want to delete it. Is it clear? Are you able to understand? If he want to delete this node, what we will do is that, okay, while I less than position, okay, then what I will do is that temp is equal to temp of next, then I will write I plus plus. Look at what will happen. I value is initially 1. Okay, position user has entered as 2. Now position is equal to 2. Now look at the condition. This is while loop. So you have a condition, you have set of statements. Okay, now 1 is less than 2. Yes, correct, 1 is less than 2. If this condition is true, what are the statements? Two statements are there. These two statements you have to execute. What is the first statement? Temp is equal to temp of next. Temp is 100. 100 of next is 200. So that you have to assign to the temp. Now temp will be 200. So it is pointing to the second node. Then you have written I plus plus. Now I value will become 2. Is it clear? Now look at here. 2 less than 2. I value is 2. Position value is 2. 2 less than 2. No, 2 is equal to 2. So this condition will be failed. If this condition is failed, it will come out from the while loop. So we have successfully reached the temp pointer to the location where you want to delete. We want to delete the node from the second location. So now the temp is pointing to the second one. So we can release this one. How we will release it, I will discuss for you. Okay? Are you able to understand? Don't assume that this is the last node. Okay? Or let me take it for you. Let me make it. Otherwise, you will refer with the what you call temp. Means tail you will refer. That I don't want. So let me take that we have another one. Here you will have 300. Here you will have the null. Okay? This value is 40. This is address is 400. Just for your understanding, because otherwise you will refer this one as the last node. I don't want it. Even think that before this node some nodes are there. Okay? Is it clear? Now tail is 400. Are you able to understand? Now this node you want to delete. Okay? How to do it? So first thing is that whatever the node you want to delete, okay, this node, previous node, this one should have this address. Am I right? In place of 200, you should bring 300 here. Then only this node will be connected to this node. Am I right or wrong? Similarly, in place of 200, here you should have 100. Then it will be pointing. Then these links will be deleted and you can release this memory. Am I right or wrong? So that's why I'm not telling that. Don't think that this is the first node. If it is, then you will say head of next, like that you will access. I want to tell the generalized one. Okay? Is it clear? Now tail is pointing to this one. So first thing what I have to do, I have to write, I need to go up to here. So what I can do, temp of next is 100, of previous I will write. Okay, look at this one. Temp of next is what? Oh, sorry, temp of next, not temp of previous, because I want to access this one. Okay, temp is 200, of previous. So you are here. Now of next, this location, what you want to write? You want to write 300, which is there what? Temp of next. Okay, so you will write temp of next. I hope you are able to understand. Let me discuss again for you. In place of this 200, you want 300. Am I right? This node address is 300. That is what you want to write it. So temp, this is the node. This is the pointer which is pointing to this node. So now you want to access this one. So temp of previous. So this node 100. 100 of next. So this location is equal to temp of next. So you will get here 300. So if you get 300, this link has been established. Okay, now you want to establish this link. How can you establish this link? Temp of next of previous. Okay, you will write temp of next of previous is equal to temp of next. So you will come here. Temp is 200, 200 next is 300. You will come here of previous. This memory location, what you should have? Here you should have 100, which is there in temp of previous. So you will write here temp of previous. Is it clear? Are you able to understand? Now in place of this one, in place of 200 we got the 100. Here in place of 200 we got the 300. So now this link has been established. This link has been established. Now still this one is there. Am I right or wrong? Now we have to release this one. So what I will do is that I will write temp of next is equal to null. If it is so, is it clear? Obviously, now this is not pointing to this one. Am I right? Because it is having 100, it is pointing to this one. Similarly, this is not pointing to this one because it is pointing to this one. Now if you write temp of next is equal to null, here null will come, so this link will be down. Then temp of previous is equal to null. Is it clear? You can write like this. So here it will become null. This link also been deleted. Now you can write free of temp to release the memory. Okay. So whatever the location 200, that memory has been successfully deleted. Then you can write temp is equal to null. Now it becomes null pointer temp. You are making it as null. Now look at here. If this node has been deleted, this connection and this connection has been established. Is it clear? Let me close the else. Let me close the user defined function called delete at position. So this is the way you will delete the node from the beginning, from the end, from a particular position in the double linked list. I hope it is clear for you. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.